Cross-validation is a resampling procedure used to evaluate machine learning models on limited data. In cross-validation, you partition the dataset into k-bins. Because you divide the dataset into separate bins, this kind of cross-validation is known as k-fold cross-validation. The k is simply the number of segments, called bins, the dataset is divided into. In the sample on screen, there are 5 bins or folds. If you have 100 samples or rows in your dataset, each bin will be 20 samples. In machine learning, rows are often referred to as samples or observations. The choice of k is usually 5 or 10, but there's no formal rule. As k gets smaller, the difference in size between the training set and the resampling subsets gets smaller. As the difference decreases, the bias of the technique becomes smaller. With each sample on screen, you'll train the model on 4 bins or folds and test the model on 1 bin or fold. Each time the model is run, it's run in the entire dataset, except for the bin or fold that's left out for testing. Each of these runs is referred to as an iteration. Each iteration will have different subsets of the data set aside for testing. Once all the iterations have been completed, the model will have been tested on the entire dataset, each time leaving out the subset of data for testing. Upon completion, an average of the scores of each iteration will be taken, and that score will be used for the model. The k-fold scikit-learn class can be used. It takes as arguments the number of splits, whether or not to shuffle the sample, and the seed of the pseudo-random number generator used prior to the shuffle. One of the great features of Python is its ability to combine libraries. Regardless of the model you choose, you can use scikit-learn's k-fold implementation to partition your data.